Hey everyone, and welcome to the Stedman SQL podcast. This is season 2, episode number 21, and I'm your host, Steve Stedman. Today I'm joined by Mitchell Glasscock as my co-host. Welcome, Mitchell.
Hey, Steve.
So today we're going to be talking about SQL Server Agent Jobs, and we'll get to that in just a moment. A couple of upfront things here. So I just want to welcome everyone to the podcast, and our podcast has been growing in popularity on both YouTube and Spotify. Our most popular episode was the February 5th, 2025 episode so far on indexing. And the next most popular one after that was episode that Derek and I did on SQL Server analysis in 30 minutes. It was on March 12th of 2025. So I just want to remind everyone, if you like the episode, be sure to click the like button. We appreciate that, and that helps get us more exposure, I think, for the podcast. And we're going to keep on doing this in year 2 now, and hopefully have another 20 or so episodes before the year end. This week's topic, as we mentioned, is SQL Server Agent Jobs. And a little bit of background on this. We do a lot of SQL Server assessments at Stedman Solutions. And one of the things that we see time and time again is people having challenges with SQL Server Agent Jobs and understanding them and scheduling them. So we've put together some new stuff in Database Health Monitor that we're going to show that will be out in the future. And we also have some tips and best practices and kind of things we like to do around SQL Server Agent Jobs that may make life easier for you or other listeners in the future. So welcome to the podcast. Let's just get started with SQL Server Agent Job tips.
Sounds good.
Well, I think at this point, I'm going to share my screen and point out a few things as we go through here. So tip number 1 that we have is really to just avoid maintenance plans. Now, maintenance plans was something I think Microsoft introduced in SQL Server 2005. It hasn't really evolved any since then, but it's a way to completely mess up your SQL Server maintenance by using their maintenance plans. And what I mean by that is that when you go into a maintenance plans, they have this great slick wizard that will walk you through a bunch of stuff, and it ends up doing really, we're not going to go through the whole plan wizard there, but it ends up giving you really bad maintenance plans. And an example of that is if you tell it that you need indexes to be rebuilt and reorganized and statistics to be rebuilt and things like that, it kind of puts them in a process where it just goes and brute force does all of those things. And I kind of like to equate it to, for instance, cleaning your garage. And imagine if your process for cleaning your garage was to take absolutely everything out of the garage, organize it out in the driveway, and then put it back in the garage in the exact spot you wanted it. And then so that's the rebuild effectively of an index, is that doing something like that. And then once that garage has just been completely reorganized in the perfect way of doing everything, you're going to go in and shuffle everything around into different places and then put it back to where you think it should go as close as you can. And that's going to be the equivalent of doing a reorganization right after cleaning out your garage. And then because the indexes were rebuilt or your garage was completely clean, you've got the absolute best statistics available. And then after that, you're going to go and reorganize your garage again, and that's kind of the equivalent of rebuilding statistics. But to make it worse, let's say you've got your garage and you've got some shelves in the garage, and 2 of the 3 shelves you have are in perfect shape. They don't need to be reorganized. Well, the way that the equivalent of maintenance plans would do that is it would go and dump out all those shelves and then put them back in the right place, even if they were already in the right place to start with. So the maintenance plans really come up with some really bad ways of doing maintenance. So we recommend using SQL Server Agent Jobs. And we also, with this, we generally recommend the Ola Hallengren scripts to replace those maintenance plans because they help with the SQL Server Agent Jobs to make things a little bit easier. So the general rule is avoid maintenance plans, do it in SQL Server Agent Jobs, and you can do things much more efficiently that way.
I think it's pretty important to add too is that the SQL Server maintenance plans are just very power hungry. They are resource intensive because they're doing, like Steve said, they're doing the entire rebuild at the beginning, they're rebuilding everything without consideration of if it truly needs to be rebuilt at that point. There's no way of saying, okay, rebuild the ones that only need to be rebuilt. It's just going to take everything out of the garage, put it in the driveway, then put it back. So they're just not good at differentiating between what truly needs work and what doesn't need work.
Okay, so this next item is on setting up a startup step to track progress so you have better insight into what's running. And I kind of got this idea after looking at a number of SQL Server replication jobs because they usually have a startup task that runs quickly and then they have a really long running task. So let me show you an example of this. I had a SQL Server Agent job that I've set up here. I'm going to go look at the properties on it. And in here, this is just demo test one, and there are 3 steps. And what we have in here is we have a startup step. And in that startup step, we'll double click and go and edit it and take a look at it. And we can see that all I'm doing is just select get date in there. Basically, I'm doing something that's fast, isn't going to really take any time. And all I'm expecting with that is that by running that, it's going to put a job entry into the job history. So when I right click here and say start job at step, and we say start at step 1, and close, what we can do is go look at the history at this point, and we can see that this one is running and that the startup step has been completed. What I like about doing this startup step that is just a really quick step that does almost nothing is that it gets something in the job history so you know that it's running. Without that, because in this specific job, step 2 is something that takes some time to run, without that, there wouldn't be anything showing up in this job history until step 2 actually completed. When jobs run, the job history is effectively empty until that step completely finishes. So if we look at this, we can see that it is now finished, and we ended up with job step 1, step 2, and then step 3. So we're able to get a little bit more information there. It's really handy to have the job steps have a startup step there just so that you can get that history and better understand what's going on.
So have you used the startup steps as kind of a way to find contention between jobs? Or what's kind of your process of doing these? If you're going to compare multiple startups or startup steps, what's your kind of process of being able to see all of that afterwards?
Well, usually what I'm looking at is I'm going to go look at the job history like we did here. If we go into view history, and I can click on this job and maybe 2 or 3 other jobs. And if we're looking at that and we're trying to look at when it started and when it ran, sure, you could extrapolate the start point on this one from, by scrolling over here, wherever the column is, how long it took to actually run, which is not as easily found as you might expect, 15 seconds there. But it's just a handy way to kind of get a better idea of when jobs are run. So, but for looking at contention, I mean, one of the things I look at, I would say it's not really related to that startup step for contention. More for contention, I'm looking at like when jobs are starting at the same time and what jobs are running at the same time, which I think is a really good lead in to me not sharing my screen and you sharing your screen, Mitch. What Mitch is going to show here is a new report that we've built for Database Health Monitor. It's not yet available on a public release yet. It'll be available, we expect, mid-August of 2025, which isn't too long after this episode airs. So if you're watching this episode after August of 2025, this will be available for you. If you're before that, stand by a little bit and you'll be able to get access to this.
So we took the previous job history, which just showed these list views of when these jobs started, but it didn't really show a good graphical representation of when these jobs were truly starting. Sure, you could look at the data and you could see that these jobs, let's see right here. So all these jobs are starting at 10:45. But if you have, say, 100 jobs on a single SQL server, it can be hard to find all those jobs that are starting at the exact same time and what's actually happening in all of them, reading the outcomes and whatnot. So we put this all into a 24-hour view where you can see the start time of each job and how long it lasted. So each of these small bars represents jobs that took maybe a few seconds to run, and they're running every, let's see, this one's running every 10 minutes. Yeah, every 10 minutes if I'm reading that right. And then these bigger bars are this do work job. There's this one's actually a bunch of single jobs that is just running over and over and over again. But do work 2, this one's starting at 11:54 p.m. and ending at 2:54 a.m. So we can see that this job is a long running job, which helps us show any of that contention that we were talking about previously. If jobs are running and overlapping at the same time, or they're starting at the same time, there might be some resource contention there.
Yep. So on that chart then, Mitch, for old guys like me whose vision is not as great as they were when they were your age, can we zoom in on that to maybe blow that up a little bit?
Yeah, so we have a bunch of handy resource views or a bunch of ways to view the chart. So if you hold control and scroll in on the chart, it'll start expanding it. And if you noticed up at the top here, it added an extra half an hour marker. So that way you can see these start and stop times a little bit easier. But we can zoom in and we can look at everything that happened at midnight, and we see these 4 jobs. So every 15 minutes is when this job is starting. One other thing that I didn't cover, if you look at the top bar here, it says 9% and then it has a little blue color. What this relates to is actually the current CPU usage for that hour. It was the average CPU usage during that hour. So it's nothing super fancy here, but we saw all the way throughout today, we've had 9% of the CPU load by hour, which also correlates to the CPU load by hour instance report.
Yep. So that's super handy. I mean, well, frankly, it's kind of boring on this server because it's our test server. But on a server that has real load, where you've got certain hours that the CPU spikes and other hours that the CPU is more available, you can use this to see which jobs are running during those high CPU or low CPU times, and maybe consider shifting your jobs around a little bit based off of when they run and that CPU utilization there.
Yeah, and we've already actually used this to see for clients that have had jobs that are overlapping and some resources that are overlapping. We've looked at it and we've seen their CPU is just spiking during these times. And we've been able to make recommendations of shuffling jobs around, changing the start times so that that CPU load is a little more even throughout the day. And in turn, creates less blocking, less locking, everything on their systems.
And then the other thing that's kind of handy with this one, if you right click on that chart, you can copy the chart to the clipboard as an image.
Yep. And it copies everything, all the headers. And then if it's a long chart, such as this one, it will copy every single job and all of its information all the way down.
I did one that was like 20,000 pixels wide when I copied it because I had it zoomed to that level. And it was really handy because I took it and put it into an image editor and then kind of zoomed in on the specific one I wanted and copied and pasted it to tell the client about it. So definitely a handy way of analyzing what's going on with different jobs there.
For sure. And then beyond just the current 24-hour view, we've also added the yesterday's view. So you're able to look back into what happened in the past 24 hours as well.
So can we go back like 30 weeks or the whole year or anything like that with this?
So we don't have the ability to go back that far because it's all coming from the SQL Server Agent job log, and that is oftentimes cleaned out after a few days. But that is, correct me if I'm wrong, that is a setting that the user can change as to how long that retention period is.
Yes, and yeah, absolutely. And that's one of those things that usually when we're doing a performance assessment and those kind of things, we try and limit that so you don't have like tens of millions of rows showing up in MSDB to track your job history. So why don't I can jump in and show more of that now, unless you have more to show here, Mitch.
I think that's a pretty good overview of what we have here. If we want to move on to the next topic.
Yeah, so what Mitch just alluded there was the job history. And if we go into the SQL Server Agent and right click on the SQL Server Agent and go into properties, there's a history tab here. And a lot of the time, people will have this set to too much history that's being kept around, so it slows things down. But what I've set mine to is The maximum job history overall is going to be 10,000 rows. And I'm just going to on this server, let's say we're going to adjust it to 20,000. And then the maximum job history rows per job is 1,000. So what that means is that if I've got 30 jobs listed over here, at most I'm going to have 1,000 entries per job. And at most I'm going to have a total of 20,000 entries. And I could say something like, well, let's remove older than 2 weeks. And that's going to help keep it trimmed as well. So when we go look at the history, that's the same tables that we're using to display that chart that Mitch just showed. This is going to control it. But what some people end up doing is they do something ridiculous, like say, okay, let's keep 1,000 entries total, and let's only keep 10 job history rows per job. Well, that means at most on that chart that we were showing, you're going to see 10 jobs being shown per row. So keeping this a little bit bigger, but not crazy big is usually I like to have at least 2 days worth of data kept in there, and we can adjust this a little bit. And when you've got jobs running that are running every minute or maybe every 10 minutes, they can add up real quick. So you want to be aware of that. Make sure it's not going to grow too much.
Yeah. So if we go back to the example of what we were showing previously, there was that one job called do work that we had in our test server, which I can, if we want to show it again. So if we look at this do work one, because it's starting this job, let's see, 23, it's starting it every minute to 2 minutes. This is going to have that job history that's cut off. If you had the extended job history or your job history was just too big by default, it would start showing this all the way back there. And that would not be cleaning out from the SQL Server Agent job history. But that's where we can see a real world example of this actually being cleaned out.
So if we were to look at that same chart today at 3 a.m. or 4 a.m. versus right now when we're looking at it at almost 11 a.m., that bar on the do work job would be showing a lot more activity in the wee hours of the morning because the history hasn't been cleaned out yet.
Right. I mean, even if we look at it, if we went later and we looked at it at 7 this evening, this entire bar would be shifted just to this side over here because it's going to be cleaning all of this out as it goes along.
Yeah, and that's the thing with the job history is that if you've got a job that's running every minute or every 2 minutes or something like that, well, maybe you don't want to keep 50,000 rows of history just for that one job.
Yeah.
And so, but the side effect is we don't have the history kept around to be able to show it in the chart like this as well. So,
right. And that's where it's important to make the connection of how long am I actually keeping my data on my system and then extrapolate that onto this chart when you're looking at it.
Okay, so let's switch back to my screen then for a minute. One of the things that we've come up with as a rule is to not reuse job schedules. And when you set up a new job, there's a schedule section here. And what I usually do when I'm setting up a schedule is I put the job name and something about the frequency in it. I'm not real specific on the frequency because I know I'm going to come change that later. Most of the time I'll just go with a job name. So for instance, my job name is Demo Test 1. My job schedule I would call Demo Test 1. Now, if I had just called this job schedule every hour, and then Mitch comes along later and schedules a job, and he sees that there's already a schedule there called every hour and takes my job schedule, then we have two jobs that are running on the exact same schedule, and they start on the exact same second every time they run. Okay, first off, well, you're going to run into contention there with the job starting on the exact same second. So one of the things we like to do is to go in and modify the jobs. So this one is one that I wanted to run once an hour, and but instead of starting at like midnight and running every hour on the hour, I shifted it to 12:05 and 22 seconds. And I always like to not run it on the hour, the 10s, the 15s, or the 30s, so that way that you don't have all your jobs starting at that exact same point in time, and 10 jobs all trying to log to the same table and all trying to run queries at the exact same second can be a problem. But back to why the other reason I don't like to name them is that let's assume I've got my job running every hour and Mitch has his job that he set up that's running every hour, And then I come in later to edit my job and say, this job really doesn't have to run every hour. Maybe every 2 hours would be more appropriate. I come in and change my job that's associated with this, set it to 2 hours. I didn't just change my job at that point if we're sharing a schedule. I also changed the job that Mitch had so that now they're both running every 2 hours. And then Mitch starts getting alerts, or somebody in management starts complaining about Mitch. Why is your job not running every hour? Well,
Yeah.
he comes back and says, oh, somebody changed it every 2 hours. He comes in and sets it back to 1 hour. And then that affects his job and my job. And now my job's running every hour. So
Yeah.
then I come back and fix it. And I've seen a ton of confusion over that. So I really like to make sure that every job has a unique name on the job schedule so that we're not duplicating schedules and having other people edit those schedules. Another thing to consider when we're looking at job steps, since we've got this open, let's take a look here. This can get a little bit confusing. But with job steps, we have 3 steps here. When this job runs, you would expect it to run job 1 or step 1, step 2, and step 3. And that is what it does. But you can do some interesting things, like let's say we added a new step here, and we're going to call it error step, and it's going to do something. I'm just going to say select get date. We'd fill that in with real code to actually go log the error somewhere later. But looking at this, you might assume that this is going to run step 1, step 2, step 3, and step 4. But step 3 has been, let me make this a little bit wider so we can see it. Step 3 has been set up so that on success, quit the job reporting success, and on failure, quit the job reporting failure. Well, given this, if we just let this run, it's never going to get to job step 4. Now, if we hit OK, we get a warning here that says, warning, yeah, it's not ever going to get there. So we're going to change it to go to the next step. Is this the intended behavior? And I could say no. So really what I want to do is if step 3, the process I'd like to have happen in this case is step 1 and then step 2, and based off of step success or failure, we either go to step 3 or step 4. So I would go in and edit this long running step, which is the one that's actually doing work. Well, in this case, I've just mocked it up with a wait for delay command, but that would be your long running procedure. And I would go in and say on success, go to step 3, which is what we want. And on failure, instead of just quitting the job, I want to go to step 4, and that's the step that's going to log something about failure. So now at this point, it would go step 1 and then step 2, and then depending on the success or failure of step 2, it would go to step 3 or step 4. Now, this can get a little bit confusing based off the graphical interface for this being simply a list that shows all the steps. But the step number does not necessarily imply the order that's being run. Now, one thing I see people do occasionally is you go down, if you're trying to test or debug something, like let's say you've got a job with maybe 10 steps, and you say, okay, well, I want to skip step 1 for testing purposes this time, so let's just have it start at step 2. You hit OK. Well, then whenever that job runs, it's going to skip step 1. Now, that might be logical in some environments, but it might also mean that you're losing some of your processing every day if somebody forgets to set that back. So being aware of what start step is specified down here is important with that too.
I think it's also important to note that in a production environment, each job, there should be a shared document with each job and its information in there, what the job is doing, the steps, the schedule, and that needs to be updated so that if someone else comes and looks at the job, they can refer back to that document and be like, oh, okay, this is the intended process that it was supposed to be on. If someone altered it, they can revert it back to its unaltered state or contact the person that made those changes. So documentation is very important when doing SQL Server Agent jobs so that everyone has access to the intended outcomes.
Yep. And 2 ways I've seen that done, and they both are effective, is like Mitch mentioned with doing a document, or maybe have a document that has all your jobs in it, but also just going in here and putting in a description. This is a demo job, runs hourly or whatever it is, and created by, oops, if I can type, created by Steve. And there we go. It just saved that there. Hopefully your documentation is more detailed than that, but you can put a couple paragraphs in there if you want, or you can go put that into a a Word document as well. So definitely good things to do there. Next, I want to jump into a little bit about alerting and things like that. And like I said, we do a lot of performance assessments and find out along the way that people don't have things configured in a way that they know that things are failing. Now, some of these jobs, we want to know if they fail. Others, well, it's not as big of a deal. And that's something that you have to decide along the way. But one of the things, for instance, that is important is the database integrity check, system databases, and user databases. Now, one of the most expensive services that we offer is database corruption repair. And we can help you if you get a corrupt database, but we would rather not bill you for 4 days of corruption repair. We'd rather help you get that figured out quicker than that. So the reason I'm bringing this up is that a lot of the corruption repair clients that we've worked with thought they had CheckDB running, or actually did have CheckDB running with something like this database integrity check, and it had been failing for 4 or 5 or 6 weeks, and they didn't know about it because they didn't have alerting configured. So setting up alerting is important, and what you can do to take a look at that is you can go into the job setup. There's a section under notifications, and we can set it up to go to a specific email. Now, this server doesn't have email configured on it. Let me switch to my other test server here that does have email configured. Notifications, here it's set to go to an email. This is an operator named Steve, that's me, and to notify me when the job fails. I've seen people sometimes notify whenever the job completes, success or failure. That's a personal preference. I don't like it because I'd rather only know about it when it fails. I mean, I trust that it's going to be running the rest of the time. So notify when the jobs fail, and I like to set that up on almost every single job. Occasionally there'll be one that we know isn't so important and occasionally might fail, but something like CheckDB or rebuilding indexes, all that kind of stuff, I want to know for sure when the job fails. So I want to have that notify me. Where that gets set up down here is under operators. And an operator is simply just an alias that defines this alias named Steve is going to actually go to this email, steve@stedmansolutions.com. And if you wanted to notify a group distribution list, you could put that in there, or you could put in multiple names separated by semicolons. You need yes. So if we go, I think you said that almost right. Let's go look here into properties. Yeah. You did say mail profile, didn't you? That is right. I was thinking of it wrong. So one of the things that we see people do wrong is they set up the agent jobs, they turn on the notification, and then it fails and they never get email. Well, that's because they have not enabled a mail profile here. And the mail profile simply references a SQL Server mail setup, which you can define in a different area that just says this is the SMTP server to be using. And then the mail profile is the name it's going to use, SQL Alerts, and you just have to enable it here. There's other settings you can do to adjust it, but that has to be turned on. If you're not getting any notification out of your SQL Server Agent jobs, it's probably because this was missed on getting it set up. One of the most popular videos on my YouTube channel, not the most popular, but one of them, is configuring database mail. And if you just go look at my YouTube channel and look at all the videos, sort by popularity, it's probably in the top 5, configuring database mail. Let's see, so we've covered that. The other thing that we like to set up with a SQL Server Agent is also alerts down here, where we have alerts for error 823, 824, and 825, and severity level 19 through 25. Now, error 823, 24, and 25 generally are errors that if you see these, there's probably something really horribly going wrong with your I/O on your system. If you have a hard drive that's about to fail, or maybe not about to fail, but just failed, and it's running intermittently, things like that, that will start throwing these errors. Errors 823, 24, and 25 are errors that if you ever see them and you care about your SQL server, you should stop everything you're doing and immediately focus on figuring out what's wrong with SQL Server because of those errors. Now, the way you set up alerts on those is you can go in and double click on these, and you can have the error number in here, but then you set the response. For the response, I want to notify this operator by email, and there's also a pager option if we set that up, but and to notify an operator, or you could have it go do a job, different things like that. But generally, if we're seeing those errors, we want to know about it right away. Now, error 19 through 25 down here are errors that their severity level is related to how bad things really are. So if I'm seeing error number 22 through 25, severity 22 through 25, I'm expecting that something's really bad's going with the system. Severity 21, there's a lot of false positives where, like, if somebody tries to connect and they're actually accidentally using their domain name from their laptop rather than the actual domain they're on or something like that, you get a bunch of false positives on 21. So I'll skip 21 sometimes, but 19 and 20 are usually ones you want to know about as well. So at a minimum, I would say configure 823, 824, and 825, as well as 22 through 25 on the severities here for notification, so you know about it right away.
So let's say someone has a production server, they have their server set up, it's been running for a few years now, and they're just getting around, they just realize they don't have any operators configured for these errors and the severity levels or the database integrity checks. Which ones would you say those need to be set up right now because they're not set up?
I would start at a minimum with error 823, 824, 825, 22 through 25, and then whatever jobs you're using for your database integrity check, for that's running CheckDB, at a minimum you have to notify on those. And I think that, well, and to put it in perspective, like backups, if your backups are failing, yes, that's going to be painful, and it might be even more painful if your system integrity, if you have a corrupt database. They kind of go hand in hand there. But if your database becomes corrupt, that can put you out of business right now. Whereas, yes, backups not happening could put you out of business next week or when you actually need the backups. So yes, I don't know how to say it right. They're super important to have your backups running, but they're not, it's like doing your exercises versus dealing with a heart attack. One of them's going to kill you right now. The other one's going to kill you over time if you don't do it right. So that's where I'd say at a minimum, it would be your database integrity checks and your error levels that we're seeing over here. And then followed immediately by database backups and anything else that's super important for your business there. Okay, so a couple other things to cover here then. One of the things is when you're working with SQL Server Agent Jobs, it's good to be able to understand what's happening when they run. And one of the things we can do is go in, I'm not going to do the database integrity check. I'll do system databases because that one's pretty quick, I think. If we go in and look at the steps, there's some things we can do in here that will give us additional information when they run. So if we go look at the advanced tab on a job step, we have the basics of quit the job reporting success or quit the job reporting failure like we saw, but there's also an output file that it will write to, and you can go view what, oh, the file's not there right now. Oh, maybe, I don't know if this one's running or not, but we'll find out. Or you can do log to table. And you know what? Because this is an integrity check, it might take a little while to run. Let's go back to our demo database, our demo server, and look at our demo test job that we're working on. And in here, when we're editing the steps, like the startup step that we talked about, we can turn on in the advanced section an option to log to a table or to log to a specific output file. If you log to an output file, you can go browse, specify a file name. Log to table, we'll put it in a table in MSDB database and log that it's been run. So I'm going to set that one to log to a table. I'm going to set this one also to log to a table. And by the way, this log to table feature is not incredible by any means. It's real basic. But output file, if you say log to an output file, it will go and you can have it create an output file every time this runs. Log to table will just have it overwrite every time it runs. And if you hit view, you can go see previous views, or you can say append the output and it'll keep appending to the same entry. So what I've done, I've just turned that on for 2 of those. I'm going to run start job at step. I'm going to run this job. I'm going to start it at step 1. And then when that runs, it's going to log into the sysjob step logs table. And we can see now there's 3 entries there. There was DB Health History 1 that was there previously, and then a job demo test 1, and step 1 and step 2. So if we wanted to go see the output from that, we could just copy this from here, open it up into a new tab, and it doesn't do a very good job on carriage return. Actually, there's not a lot of output on that one, but we can go and see that it started, it began, step 1 began executing at this time, and then the 1 rows affected is the only thing that was printed out from that job step. Had there been other output or errors or things like that, you would have seen it here. And this is a handy way to be able to diagnose what's going on with a job. Although I haven't found out a good use for using this log to table on an ongoing basis other than temporarily using it to diagnose problems. Okay. Well, I think then, Mitch, anything else that you can think of we want to cover here?
No, I think we got some good depth on doing the jobs and the job scheduling and a little bit of a sneak peek of what's to come for Database Health Monitor.
All right. Well, then I guess at this point, let's wrap it up. I'd like to thank everyone for watching or listening today. I'd like to thank Mitch for joining me as my co-host. And we hope that you've enjoyed the episode. Join us next episode for another exciting SQL topic. If you want more episodes, please take a look at our YouTube podcast channel, where this episode and all of our other episodes are located. And you can get that at https://stedman.us/podcast YouTube. This is Season 2, Episode 21. Thanks for watching. Have a great day. Thanks for watching our video. I'm Steve, and I hope you've enjoyed this. Please click the thumbs up if you liked it, and if you want more information, more videos like this, click the subscribe button and hit the bell icon so that you can get notified of future videos that we create.